metric conversions. Oh my God, why can I not spell tomorrow? Is that right? My brain just went like, psst. I've known how to spell tomorrow since I was like in elementary school. I don't know. Today I'm just like, are there 2 M's or 2 R's? I don't know. Brains sometimes go kaflooey. So you have to remember, if you have a prefix unit, remember it's kind of like the mountain. And over here, there's another mountain, which is the prefix unit. In between, you have to go through the plane unit. So this is going to be 1 step, 2 steps. What is the other thing that you need to remember when you're doing metric conversions? If you're using those powers of 10. Actually, first thing you need to know is that. Second thing you need to memorize: mega, kilo, deci, centi, milli, micro, nano. Six, 3, 1, 2, 3, 6. 9 is for the nano, okay? Now, if you know other conversions, like let's say you've taken physics and you're like, I know that there are 10 to the positive 9 nanometers in a meter, you can use that. I'm only teaching you one method because otherwise it's too complicated to teach many methods. I'll just confuse you. Okay, but if you know other conversions that work, feel free to use them. I can deal with them all. Okay, so that's the first thing, the second thing, and now what is the third thing that you need to remember? You all said yesterday, I will never forget. I will never forget this. The 1 goes with the what? Prefix. The 1 goes with the prefix. Everyone sing with me. The 1 goes with the prefix. 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 All right, very good. All right, so that's going to help you remember where those go. If you have these skills, you should be fine. The other thing you need to remember is if you have a slash, like let's say you have decigrams per microliter or something like that, you need to rewrite it as decigrams over microliters so that you know that the microliter is on the bottom, not on the top, okay? So those 4 things should probably get you through. If you're doing a rate conversion where you have one number over top of another number, feel free to do it all in one line or convert the top, convert the bottom, and then divide, okay? But today, we are going to take a look at density. So I would like you to define for your partner the word density.
Density of items.
Okay, my friends, what is density? Who can give me a definition of density? Yes, Sky.
The amount of mass contained in a volume.
The amount of mass contained in a volume, yes. And if we were to take that sentence and make it into an equation instead, if we replace the density with D, density is equals the amount of mass in a volume. D equals M over V. Yes, D equals M over V. Now, what I would like you to do is I would like you to see if you can do the algebra around solving that for M and solving it for V. Have we solved for V? Is V equal to D times M, or is V equal to D over M, or is V equal to M over D? Which of those three is correct? Yes.
V equals M over D.
V equals M over D. Now, if you're like, how? How does V equal M over D? We can go through that. There's a couple of ways of doing it. So V is equal to M over D. Let's just, I'm just going to pop over to the side here for a moment. There we go. D is equal to M over V. Now, you want V by itself. So there's a couple of ways of doing this. Number one, you can say, this is over 1. I can take the V. I have to move it which direction? Up, down, side to side, or diagonal? I have to move it diagonal. So now I have V times D equals M. And remember, I still have denominators here. Now I can take the V. Nope, sorry, not the V. I wanted the V. I'm solving for V. So now I need to take the D and move it down. So that's going to give us V equals M over D. That's one way of doing it. Other ways that people really enjoy doing it, like doing it, their preferred method, maybe that's better than saying they enjoy doing it this way. You don't want V in the denominator, so you can multiply both sides by V. That will cause V to cancel. Yes? So you are now left with V times D equals M. You want V by itself, so you can divide both sides by D. The D's cancel here. And once again, you get V equals M over D. I don't mind which method you use. If you can just do it in your head, that's great. If you want to show your work, whichever method you use, as long as you're getting the correct answer, that's great. Now, to be honest with you, I don't even care if you use this formula other than the D equals M over V, because you can just use density as a conversion factor, and you can use the conversion factor method. Okay, so we're gonna do all of those today. Now, what if we take D equals M over V and we solve for M? What do we get? Do we get M is equal to D over V? M is equal to D times V? Or do we get M is equal to V over D? Yeah, sorry. M is equal to D times V. Yes, that is absolutely correct. And again, if you have problems with that, just move things diagonally or do the thing where you multiply things out and divide things out so you end up with it on it by itself. Okay, mass, quantity of matter, volume, the amount of space taken up, density is the mass in a given volume. Here's our formula. And now we're going to do a question. This is on page, what page did I say it was on? 83, but I'm going to shuffle over here. It's all worked out for you, but I'm going to do it from scratch. So if you want to do it from scratch with me, just have some blank paper. The question is, what is the iron's density? The only way to find density is to use the density formula. Density equals mass divided by volume. There's no unit conversion you can do here. You're doing a division, you're not like doing anything else. So our mass, 19,600 grams. Our volume, 2.50 liters. It doesn't specify which unit to use, so we can just leave it in grams and liters. So do you kind of like this question? Is this pretty straightforward? 19,600 divided by 2.5 equals 7,840. What do you think of that answer? It needs a unit. What unit do we have? We have both grams left and liters. The grams are going to go on the top and the liters are going to go on the bottom. Do we have correct sig figs here? 3 sig figs, 3 sig figs. Oh, look, 3 sig figs. So we're good. Okay. So finding a density is very easy. All you have to do is take the mass and divide by the volume. Do you need to memorize this formula? Yes. And the reason I'm saying yes is because you have probably been doing something resembling density since grade 8. So memorize this formula. Number 2, if mercury has a density of 13,600 grams per liter, what does that look like? Grams over liters. That looks like a conversion factor. You can use density as a conversion factor. So our unknown, what volume? Our unknown, we don't know what volume, oh, in milliliters, is occupied by, now if anyone has missed this up till this point, do you notice how what volume is attached to 425 grams? Do you notice how those two are attached in the sentence? What volume is occupied by 425 grams? Those are connected. The unknown is always connected to the initial. Whoops. Why did I not put that over there? Let's do that again. Volume grams. Unknown is connected to the initial. So what that means is, what is my initial quantity? My initial quantity is 425 grams. And I said we can use density as a conversion factor. So our conversion factor, 13,600. Should I write it as a slash or should I do something else? Should I write it like this? No. What should I do instead? 13,600 grams over a liter. Okay. Excellent. How do I set up the problem? Is it conversion factor is equal to unknown times initial? Is that correct? No. Is it initial is equal to the unknown times a conversion factor? No. We want to solve for our unknown. It was almost correct. We want to solve for our unknown. And it's going to be equal to our initial quantity, what we're starting with, times a conversion factor, or maybe more if we need them. This case, we won't. We'll just need one. Fill them in. What is our unknown? Yeah, how many milliliters? Equals. What is our initial quantity? 425 grams. Absolutely. There we go. 425 grams. And now we're going to put in our conversion factor. Now I'd like you to think about, don't write this down, just critique what I'm doing. 13600 grams per liter. Tell me how you feel about, actually tell your neighbor how you feel about that.
All right.
What would our unit be if we were to actually do this calculation? We would have grams times grams over liters, and that would give me grams squared on the top and liters on the bottom. Is that a happy unit or is that a sad unit? That is a sad unit. So we do not want that. That means that if I've done that, I've put my units in the wrong place. Remember, you need to say grams are on the top, so I need to put grams on the bottom, which means that the liters need to go on the top. All right. And we know that there are 13,600 liters per gram. Is that correct? No. So don't just go throwing in numbers. Make sure that you look back at your conversion factor and say, what does the 13,600 go with? It goes with the grams. Now, what were we looking for? We were looking for milliliters. Are we at milliliters yet? No. What do we need to do to convert between liters and milliliters? I'm going to use our power of 10, okay? What does milli mean? Milli means -3, 10 to the -3. So where does the 1 go? With the prefix. So 1 goes with the milli, and then that means that the 10 to the -3 goes with the liters, okay? So now we have check that in your calculator, see if you get the same number as I do. Divided by 13,600, divided by 1e3 negative equals, I get 31.25. Is that what you get? And if you're not plugging it into your calculator, you won't know if you know how to use your calculator or not. Plug it into your calculator.
Oh, this does it matter if you go like 1,000 milliliters over 1?
No, that's totally fine too.
Like, I see.
Yeah, no, I get you. That's what I would do too.
What's the difference usually like 1 milliliter over 10?
Yeah, the only reason is because is if you're using something other than milli where you don't know it as well, like deci,
Yeah.
you might be like, okay, well, I guess I'm gonna use the power of 10 for the deci. But yes, please feel free to use the more familiar conversion factors. That's what I would do. Are you getting 31.25? Anyone not getting that? Want to check on their calculator at all? All right. Is that a good final answer?
No.
No. There's 2 things wrong with it. What's the first thing wrong with it? Sig figs. So we have 1, 2, 3 sig figs, 1, 2, 3 sig figs. All of these are exact, so they have infinite sig figs, infinite, infinite, infinite. So we need 3 sig figs, boom, boom, boom. So that's going to round to 31.3. Done. No? Yes. What do I need? I need my units. What are my units? Let's check it out. My grams have canceled. My liters have canceled. The only thing I'm left with is milliliters. Are we good? I didn't hear anything. Like I totally missed what happened. So it's all good. Is good? Excellent. Okay. So feel free to use density as a conversion factor. However, should you prefer to use the density formula, this is what you would need to show for your work. So don't just think, oh, I can do the density formula. I can just fling things together. Don't have to worry about units. Life is good. I'll just do that. That sounds much easier. No. If you're using the density formula, you still need to write your unknown. What volume? Okay, and the other thing you'll need to do is you'll need to say, I have my mass is equal to 425 grams, and my density is equal to 13,600 grams per liter. Now you will take your density formula. Density equals mass over, whoops, not all over, mass over volume. You need to solve that for V. Solve for the unknown. And in this case, V is equal to M over D. Okay? Right? All the info. That's step number 1. Step number 2 is to solve for the unknown. Step number 3 is to sub numbers and units into the formula. So you're going to make a nice little mathematical sentence. So what it's going to look like, it's going to look like, I am solving for V. What is V equal to? V is equal to M over D. What can I substitute for mass? I can substitute 425 grams. And what can I substitute for D? 13,600 grams per liter. And I get 425 divided by 13,600 equals, am I not getting the same answer? Oh yeah, I am. And I get 0.03125. What is the unit? It's liters. So at that point, you would need to convert it to milliliters because you've been asked to convert it to milliliters. Do any necessary conversions. Okay, so you have 0.03125 liters times, and you know what? If you like using 1,000 milliliters per liter and you're like, that's way easier than 1 liter per 10 to the negative 3, or no, sorry, 10 to the negative 3 liters per milliliter, or 1 milliliter per 10 to the negative 3 liters. If you like this one better than that one, you go for it, no problem, because we're really familiar with that one, I hope. And you get 31.25, and then you round it to correct sig figs, 31.3, and you say, hooray, I am done. All right. There is one more example, but it's pretty much the same. Yeah? Do you want to do the other example, or do you just want to try these? Okay, so those of you who want to try, you are just going to go ahead and do the exercises, okay? Anyone wants to work through the next example with me? We're going to do it together. Okay. So let's, in this case, we're going to use density as a conversion factor. And if we're using it as a conversion factor, it would be a really good thing to rewrite it as 10.5 grams per centimeter cubed. Okay, so that's our conversion factor. Find the mass. Find the mass. That is our unknown. I'm going to guess it's in grams. Why not? That occupies. Oh, look at this. Yes. This one is on page. Oh, it's on page 85. So if you look on page 85, it's right here. Yeah, no worries. Page 85, right there. So our unknown is the mass in grams. And do you remember that the unknown on cow? I forgot my N. Unknown is connected to the initial quantity. Find the mass of what? Find the mass of 965 centimeters cubed. So our initial is 965 centimeters cubed. You guys are going to tell me which one of these is correct. My initial is equal to my unknown times my conversion factor. My conversion factor is equal to my initial times my unknown. My unknown is equal to my initial times conversion factor. Which of those do you like? Number 3. Yes, that's the one we want. So what is our unknown? Our unknown is the number of grams. What is our initial quantity? Our initial quantity is 965 centimeters cubed. And our conversion factor is the density. So I want you to ask yourself, do I want to use 10.5 grams per centimeter cubed, or do I want to use 1 centimeter cubed per 10.5 grams? Which one? What do we want to cancel? We want to cancel centimeters cubed. So centimeters cubed are on the top, so they need to go on the bottom. And what goes on the top? The grams go on the top. So we look here and we say, what goes with grams? 10.5 goes with grams, and 1 centimeter cubed goes on the bottom. 965 times 10.5 is 10132.5. Whew, that's a big number. How many sig figs should we have? 3 sig figs. 3 here, 3 here. So that's going to become 101, yes? 0, 0, thank you. Because if it was 101, that would not be the same as 10,000, yes? And our unit would be grams. Centimeters cubed cancel out, and we are done. Anyone want to see it using the formula? Yes? Okay. So for anyone who wants to use the formula, I'm going to show that. If not, feel free to go and work on those questions. It would be the exercises on pages 86 and 87. Now, the rest of the questions after 87 are challenge questions. So you can do them if you want to, but there is no need to. Okay? So all of page 88 is challenge, enriched stuff. Okay? Okay. Using the formula. We say, okay, what is D? D is 10.3, no, not 10.3. D is 10.5 grams per centimeter cubed. What is M? M is, oh, it says find the mass, so we don't know the mass. And what is V? V is the volume. We're given the volume here, 965 centimeters cubed. So we write out the info. Number 2, we solve the equation for the unknown. In this case, M. So we need to take D equals M over V and solve for M. M is equal to D times V. And then the third thing we're going to do is we're going to sub in the numbers and units. So we're looking for mass. It's equal to density times volume, which is equal to 10.5 grams per centimeter cubed times volume, which is 965 centimeters cubed. Look at that. What unit am I left with? I'm left with grams. Okay. 10.5 times 965 equals 10132.5, and then that would round to 10100 grams. So you can solve density problems either way, using density as a conversion factor or using the density formula. Your choice. Homework. Page 86, 87. But I also want you to make sure you are ready for your quiz tomorrow. So if you prefer, you can do every other question. Do you know what I mean? Just so it's not so much. So maybe do the odd questions. Because the second thing you're going to do is you're going to study for tomorrow's quiz, which means you're going to make sure that you have done. Let me find the pages. Ooh, there's a metric conversions review, 79, 80, 81.
All this stuff. Can I use the water?
Yes. Actually, I'm gonna say this should be number 1 and the other one should be number 2. If you don't get around to number 2 because you're too busy with number 1, that's okay. So number 1, study for the quiz. Number 2, do that. Hi.
Can we redo the quiz?
Can you redo the quiz?
Yeah.
Yes. Absolutely.
I'm jumping for joy.
Quiz.
I'm jumping for joy, like you said. I'm at like.
Now we only have 5 minutes right now. You good with that?
We can go into lunch a bit.
Yeah.
Okay,
No problem. Yeah. Just throw up the divider between you.
Yeah. Thank you.
You do not have to do things. Okay, but just so you know. Okay. You can do the odd numbers on 79, 80, 81. And if you're finding it all really easy, page 82 has cubed and squared units.